Good morning. Today is December 9th, and we are going to move right along with lesson 6-4 and take a look at rectangles. So if you look over at the hierarchy that's to the right of the board here, you'll see that rectangles fall right below a parallelogram. Okay, so what that means is a rectangle is a parallelogram. It's just kind of a special kind of parallelogram. Okay, so what that means is all of those properties that we looked at last week, all of those properties still apply. Okay, so opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Diagonals bisect each other, and consecutive angles are supplementary. Okay, so all of that still applies to rectangles. Okay, let me start with the definition of a rectangle, and then I'll share with you some additional properties of a rectangle in addition to the parallelogram ones. So a rectangle is defined as a quadrilateral with 4 right angles. Okay. So just based on the definition, this is like the typical view of a rectangle, just 4 right angles. Okay? So once we know that something is a rectangle, there's one additional property. This one additional property is that the diagonals are congruent. Okay? So if I draw in the diagonals, they are congruent with one another. So if I just throw some letters on here, A, B, C, D, this means that AC is congruent to BD. Okay, so that's really the only additional property. Otherwise, we would say that all properties of parallelograms apply. Okay, so you're like, and I just listed those. So like your opposite sides congruent, opposite angles congruent, etc. All of those are still true of a rectangle. Okay, so I just have 2 quick examples to show you. The problems that you're going to see in your assignment today are going to be very similar to the ones that you saw with a parallelogram, only now, of course, they're going to relate to rectangles. Okay. So here's the first example. I'll start out with a more basic looking example, and then I'll get to a little bit more complex one. Okay, so if RSTU is a rectangle, and actually I have 2 problems that are going to go along with this. So here is RSTU. Draw on the diagonals, and this place where they intersect, that's going to be V. Okay? So our first task is if US equals 6x plus 4 and RT equals 7x minus 4, we want to find x. Okay, so again, I'm going to do another problem using the same picture, so I'm not going to mark it up too much. All right, so if you look at what these segments are, US and RT are both diagonals. Well, according to that additional property that I had on the previous slide, the 2 diagonals are going to be congruent to one another. Okay, so what that means is we can set these two segments equal to each other so that we can find x. So if I go 6x plus 4 equals 7x minus 4, okay, I'm going to subtract the 6x from both sides. So we get 4 equals x minus 4, and then we just have to add 4. So it looks like x equals 8. And in this one, that's all we had to find. Okay. The other one that I want to do using this exact same picture, the information is going to be presented just a little bit differently. Okay. So in this one, US equals 5x plus 3 and RV equals 4x. Okay, so again, this one is presented just a little bit differently. So if we look and see what these are, well, US, that is a complete diagonal. RV, well, that's just half a diagonal. Now here's where these properties of parallelograms are going to come into play. We know that the diagonals bisect each other, right? So if RV is 4x, VT would also be 4x, right? So in this case, we can say that US equals this full thing once we know that, okay, well, instead of 4x, it's actually going to be 8x, okay? So we're going to say that 5x plus 3 equals 8x, okay? So you just got to pay attention to what these are. They're not always going to be full diagonals. That's kind of my point with this one. So if we subtract the 5x, we get 3 equals 3x. And then when we divide, in this case, it looks like x equals 1. Okay, so you're going to see a couple of them like that. Yes, these are both diagonals, but just remember that you can see some where maybe the opposite side, it would involve the opposite sides or the opposite angles, etc. Okay, my other kind of example looks like this. And we saw these, I believe there was one of them in your 6-3 assignment. And I told you that I would do a few more of these with you. So in this one, quadrilateral ABCD has vertices A at -2, 1, B at 4, 3, C at 5, 0, and D at -1, -2. Is it a rectangle? Okay, and there are actually two different ways to do a problem like this. Okay, and I'm going to show you both of them just so that you can see them. So two things that are very specific about a rectangle is that it has 4 right angles. The other thing that is very specific to a rectangle is that the diagonals are congruent. Okay? So there are two different ways of doing this problem. You don't have to do them both. You can just choose one, but I'm going to show you both so that you can see what your options are. Okay? So if we want to show 4 right angles, in other words, perpendicular sides, we're actually going to use slope to do that. Okay? Because we know that perpendicular slopes are going to be opposite reciprocals of one another. Okay, so I'm just going to do a rough sketch. So it looks like I want to find the slope of 4 different sides, and I want to see if these angles are right angles. Remember that the slope formula, y2 minus y1 over x2 minus x1. Okay, so let's first figure out the slope of AB. Here we go. So 3 minus 1 over 4 minus -2 turns into a +2. So that would be like 2 over 6 or 1/3. So this slope is 1/3. And I'm just going to write it there so that I remember what it is. Okay. Let's find BC. Okay, so 0 minus 3 over 5 minus 4, that is negative 3 over 1. Sweet, we have an opposite reciprocal, so that means we have one right angle. Okay, let's compare that slope to the one for CD. So what? Negative 2 minus 0 over negative 1 minus 5. So that's like negative 2 over negative 6, or positive 1/3. Alrighty, so we know that's true. Okay, let's just double check the slope for AD. So negative 2 minus 1 over negative 1 minus negative 2 is like plus 2. So that's like negative 3 over 1. Looks like. Okay, so we just showed 4 right angles to show that it was a rectangle. Okay, so that's one way you can do it. The other way you can do it is with diagonals. So if we can show that the two diagonals are congruent, that's enough to say that it's a rectangle. So this one we're going to use distance formula twice. Okay, so really, I mean, at the end of the day, it's probably about the same amount of work. Okay, if you do distance formula twice or slope formula 4 times. Okay, so I'll leave that up to you. Unless it specifically says, you know, to use one or the other, of course. Okay, so let's find AC. So 5 minus 2 is like plus, or minus negative 2, excuse me, is like plus 2. And 0 minus 1. So we have 7 squared plus negative 1 squared. So that would be 49 plus 1, or square root 50. Okay. Now let's see if we get that for the other one. So negative 1 minus 4 squared plus negative 2 minus 3 squared. Things are looking good. We have what? Negative 5 squared, negative 5 squared, 25 and 25. We just did it again. Okay, so again, 2 different ways of showing that it's a rectangle. Now, if it doesn't specify which way to do it, you can pick either one. It might say use distance formula to show that it's a rectangle, in which case you'd have to do the diagonal method. It might say use slope formula to determine whether it's a rectangle. In that case, you use the 4 right angles. Okay, so I just wanted to give you both of those options so that you have more tools in your tool belt. Okay. So for the rest of the time, you can work on your assignment, which is also on the sideboard, but it's on page 344 to 346, numbers 2 through 6, the evens, 8 through 20, the evens, and 46 and 47. Okay, I will be back tomorrow. I'm at a student council thing today, so I'll be back tomorrow, and I will also hand back your quizzes tomorrow as well. Have a wonderful day, and I will see you then.